Everyone, my name is Nikita. I am from EC branch. My subject is chemistry and my topic is environmental measures to prevent corrosion. Objectives: what is corrosion? Classification of corrosion, mechanism of corrosion, types of corrosion, prevention methods. Introduction: corrosion is defined as unintentional destruction of a solid body by chemical or electrochemical reaction starting from the surface. Non-metal corrode by chemical reaction and metal mostly by electrochemical reaction. Metals are the only high energy level and hence there is natural tendency to go to the low energy state, that is, then they try to form oxides, hydroxides, carbonates, sulfides, etc., depending on the type of environments to which they are exposed. Here we can see the diagram, which is corrosion. Corrosion is a natural process that converts a refined metal into a more chemically stable oxide. It is a gradual destruction of material, usually a metal, by chemical or electrochemical reactions with their environment. Corrosion engineering is the field dedicated to controlling and preventing corrosion. The chemistry of corrosion is complex. It can be considered an electrochemical phenomenon during corrosion at a particular spot on the surface of an object made of iron. Oxidation takes place and that spot behaves as an anode. The electrons released at this anode spot moves through the metal and go to another spot on the metal and reduce oxygen at this spot in the presence of H+, which is believed to the available from carbonic acid H2CO3, formed due to dissolution of carbon dioxide from air into water in moist air condition of dissolution of other acidic oxides from the atmosphere. This spot behaves as a cathode. Here we can see chemical versus electrochemical reactions. Chemical reactions are those in which elements are added or removed from a chemical species. Electrochemical Electrochemical reactions are chemical reactions in which a chemical species, but at least one of these species undergoes a chemical change, and one of these species undergoes a change in the number of valence electrons. Corrosion processes are electrochemical in nature. Classification of corrosion. Here we can see the two classification of corrosions. They are dry corrosion and wet corrosion. First of all, we can note about the dry corrosion. Dry corrosion occurs when the metal are exposed to gaseous environments. The extent of corrosion and prevents values depending on the following factors: affinity between the environment and the metal, protective value of film, nature of film formed, adhesion between the film and the metal surface. For non-ferrous film, the extent of corrosion depends on the electric and ionic conductivities of the film. Pilling and Bedworth rule. This rule gives the idea about the nature of the film formed, that is, whether the film is porous or non-porous. Volume of oxide. Pilling and Bedworth ratio. Bedworth ratio is equals to volume of oxide divided by volume of equivalent amount of metal consumed around oxygen is equals to md by small m capital D. Formation and growth of film. The formation of growth of film occurs by three successive stages: adsorption, chemisorption, growth of film, growth of non-porous film, growth of porous film. Second one is wet corrosion. Wet corrosion occurs when a metal or an alloy comes in contact with an aqueous solution of salt, acid, or alkali by an electrochemical type of reaction. When the metal is immersed in an aqueous electrolyte, it dissolves and dissociates into metal ion plus electron. This tendency of metal is called as electrolytic pressure or solution pressure. These the dissolved ion from the solution tend to deposit on the immersed metal surface oppose the solution pressure of metal. This tendency is called as osmotic pressure of metal ion. When these forces become equal, equilibrium is reached and equilibrium is reached, and under this condition a defined number of electrons accumulate on the metal surface and defined potential will be developed on the metal piece. Types of corrosion: general corrosion, pitting corrosion, corrosive corrosion, intergranular corrosion, stress corrosion cracking, erosion corrosion, cavitation corrosion, corrosion fatigue, hydrogen blistering, high temperature corrosion. Green uniform corrosion. Corrosion proceeds at the same rate throughout the area exposed to the environment, and there is no clarity defined another and cathode area. These extent of corrosion can be expressed by loss in weight per unit area or by average penetration depth. Pitting corrosion. Small anodic area and large anodic area results in high anodic current density, leading to rapid corrosion of small anodic area, forming pit or pinholes. This result in a rapid perforation of metal sharply reducing the mechanical properties of the component. Pitting has no more effect on fatigue strength. Pitting corrosion can occur under following situations: due to break in the protective coating, due to destruction of passive layer at few points under certain environmental conditions. Differential aeration corrosion may lead to pitting corrosion. Intergranular corrosion. This type of corrosion occurs at the gain boundaries or at the region adjacent to the gain boundaries due to precipitation of some phase at the grain boundaries. This precipitate phase makes the material sensitive to corrosion. The gain boundary phase or the region adjacent to grain boundary become anodic and get preferentially corroded. This type of corrosion can occur even without the precipitation of the phase at the gain boundaries. This is because the gain boundaries region, being high energy region, will give performantly corroded due to the low temperature potential compared to the electrode's potential to gain. Example: corrosion of Austerlich stainless due to precipitation of complex chromium carbide along gain boundaries. Yield decay. Cathodic protection. To prevent corrosion, the active sites on the metal surface are converted to passive sites by providing electrons from another source, typically with the galvanic anode attached on or near the surface. Metals used for anodes includes aluminum, magnesium, or zinc. While cathodic protection is high, effectively anodes get used and need to be checked or replaced often, which can drive up cost of maintenance. They also increase the weight of the attached structure and aren't always effective in high resistivity environment. Barrier coating. Barrier coating. One of the earliest and cheapest way to prevent corrosion is to use barrier coating like paint, plastic or powders or including epoxy, rails, nylon and urethane adhere to the metal surface to create a thin film. Plastic and wax are often spraying onto metal surface. Paint acts as a coating to protect the metal surface from the electrochemical charge that comes from corrosion compound. The paint systems are the combination of different paint layers that serve different functions. The prime coat acts as an inhibitor. The intermediate coat adds to the paint's overall thickness, and the finish coats provide resistance to environmental factor. The biggest drawback with coating is that they often need to be stripped and repelled. Coating that aren't applied properly can quickly fail and lead to increased levels of coating contains volatile organic compounds which makes the hazardous to people and the environment. Corrosion prevention methods. Inhibitors is a substance which effectively decreases the corrosion rate of a metal when added in small amount to the corrosion environment. This substance controls the anodic or cathodic reaction, reducing the corrosion of metal. Anodic inhibitor, cathodic inhibitor. Anodic inhibitor, when added to the electrolyte, combine with the newly formed metal ion at the anode and form a precipitate. These precipitate deposit on the anode surface, forming a protective layer which stops or reduces the corrosion. Thus, the local anode areas get polarized, that is, increase in potential occurs at these areas. And inhibitors work effectively when they are added in sufficient amount. Cathodic inhibitor. Cathodic inhibitor reduce the corrosion by stopping the cathodic reaction. In anodic electrolyte, cathodic reaction is of hydrogen evolution type. In such case, corrosion can be reduced by reducing the dispersion of hydrogen into the cathode or by increasing over potential of hydrogen. The diffusion of hydrogen ion is reduced by using certain organic compounds. Hydrogen over potential is increased by adding salt as As, Bs and Bi. Standard related to corrosion protection techniques. Cathodic protection of steel in concrete products and systems for the protection and repair of concrete structure. Definitions, requirements, quality controls, and evaluation of conformity. Difference between dry corrosion and wet corrosion occurs in the absence of moisture. Wet corrosion occurs in the presence of conducting medium. Involves direct attack of chemical on the metal surface is dry corrosion. Wet corrosion involves formation of electrochemical cells. Dry corrosion slow process. Wet corrosion is rapid process, which means fast. Corrosion products are produced at the site of corrosion. Corrosion occurs at the anode, but rust in deposit at cathode. Dry corrosion process of corrosion is uniform. Wet corrosion depends on the size of the anodic part of the metal. Protective measures against corrosion. Metallic coating. Electroplating. A coating metal is deposited on the base metal by passing direct current through an electrolytic solution. Metal cladding. The basic the base metal at the protected and coating metal are sandwiched by processes through rolling under the action of heat and pressure. Hot dipping. The base metal to be coated is immersed in a bath of the molten coating metal. Commentation. A uniform surface coating is obtained by heating the base metal in the power of coating metal. Metal spraying. The coating metal in molten state is sprayed on metal by means of spraying gun. Organic coating. Applying on metal surface for protection from corrosion and also to impart decorative values such as paints, enamel, varnishes, etc. Corrosion inhibitors. Substance which when added in a small amount in an environment reduce the rate of corrosion of metal exposed to the environment. These are the two types of cathodic and anodic. Inorganic coating. Inorganic coating are produced by chemical or electrochemical reaction at a metal surface to protect base metal from corrosion. Example: phosphates, oxides, etc. Using pure metal, using alloy. By modifying environment, by lowering the lamp, by reducing the moisture, by reducing the acidic corrosion environment. Proper design. Proper designing. Proper designing of equipment avoid the direct contact of dissimilar metals. Electrochemical protection or cathodic protection. Sacrificial anodic protection. Metal to be protected is connected to more anodic metal to avoid corrosion. Impressed current cathode protection. This process consists of connecting the material to be protected to negative terminal of DC source, and positive terminal of DC source is connected to insoluble anode. The current supplied is in opposite direction to the corrosion current. Then the metal is to be protected act as anode and gets protected. Conclusion. Thus, we understand the basics behind corrosion and its aspects in practical life. We also looked at various aspects of corrosion control along with two case studies. Thus, the presentation underlines the importance of corrosion control and its significance for the model world. Corrosion is a natural degenerative process affecting metals, nonmetals, and even biological system like the human body. Corrosion of engineering materials leads to significant losses. And an understanding of the basic principle of corrosion and their applications in the design and maintenance of engineering system results in reducing loss considerably. Thank you.